So my good old favorite student, Anne. Two marks, 4 questions. I'm going to go a half mark for each one. Linnea is saying, how come he spells it with a Y sometimes and sometimes with an E? I know, Linnea, those things drive her crazy. Because I know it drives her crazy. That's why I spell it with a Y sometimes and sometimes with an E. I know my audience. Is that what you're asking? See, I know my audience. I know exactly how you're thinking. You should be a little creeped out by that. Half mark for each one. True or false? By the way, book sitting on a desk, I'm looking at the binder in front of me or next to me. There are no forces acting on it since it's not accelerating. False. What are the forces acting on it? Get the obvious one. Yeah. And it must be another one, otherwise it would be accelerating. The magnitude of the normal force between the book and the desk equals the magnitude of the gravitational... And by the way, I know it says magnitude, but I unfortunately don't have this in my original Word anymore, and so I'd have to retype the whole quiz, and I'm too lazy to do that. I notice Linnea also notices those things too. So, true or false? True? Yeah, I think so, right? You're imagining your free body diagram, get the obvious one. Oh, but look, and they would be equal here. The net force on the book is equal to 0. True? Friction is what's holding the book on the desk. Taylor? How do you know? Whenever we're talking about friction, what's my go-to? I imagine replacing it with ice, and I ask if it would still work. And perfect ice that has absolutely no friction, because I know you can sort of walk on ice in real life, but let's imagine perfectly frictionless ice. Okay. So, what did we say? False? Half mark for each of those. Find the acceleration of the entire system. This is a job for a free body diagram. I'm going to have M1G, normal force 1, friction, no, tension, M2G, normal force 2, applied. Who's winning? I would say to myself, self, F applied, minus tension plus tension minus M1G? No. Equals M1 plus M2 times A. Tension cancels. I end up with A equaling F applied divided by... Put your pencils down, look up. Now that we've done this a while, let me explain, because the fact that we don't use M1G has always bugged kids, because they're saying, so what are you saying, Mr. Dewick? This mass doesn't affect anything at all? It does. Look where it appears in my final expression for acceleration, on the bottom, which means the bigger this mass, the smaller the acceleration. What's causing it to accelerate slower is not gravity, but the actual inertia, the actual mass of the object itself. It does appear in the equation, but not as mg. It's not a gravitational thing. This would still work. Would this work in outer space? I think so. I have to run some numbers. Okay? So it's going to be 24 divided by 20? Is that right? Which is going to be divided by 4, divided by 4, 6, 1.2. If you got that, 2 out of 2. Otherwise, I would probably go 1 mark for that line, half mark for that line, and a half mark for the answer. I care much less about the answer. I'm arguing, Taylor, if you can get the main equation, that's the ball game. Because really the math we've been doing after that, even the formula manipulation we'll be doing after that, you may have noticed in forces, your equations actually end up being not too shabby. It's getting them. That's the tricky part. Find the tension between two masses. I'm going to go tension equals M1A. You could also go 24 minus tension equals M2A, but I cleverly picked the one where tension is by itself already. It's going to be 8 times 1.2. I should be able to do that in my head. It's going to be 8 plus 1.6. 9.6 newtons, yes? 2 out of 2 if you got that. Otherwise, I would give you 1 mark for that, half mark for the numbers, and a half mark for the answers. Now, number 3 says, find the acceleration if there's friction. So I'm going to add that in black. mu equals 0.12. And the pulling force has to get changed. Why does it have to get changed? Because when I first made this question up, it turned out 24 was no longer enough to get it to move in the first place, and the answer would have just been 0. So now I'm also going to have to add friction force number 1, friction force number 2. Sarah, I'm going to argue my equation doesn't get tougher, it gets longer and uglier. It's going to be who's winning? F applied, and then there's going to be minus friction 2 minus tension plus tension minus friction 1, and that equals M1 plus M2 times A. Tension still cancels. I'm going to get A equals F applied minus friction 2. You know what? Friction 2 is what times what? It's going to be mu times normal force number 2 minus mu times normal force number 1 all over M1 plus M2. It's going to be F applied 50 minus 0.12. I don't know normal force number 2. Oh, but look. I don't know the force that's the same size as normal force number 2. 12 times 9.8 minus 0.128 times 9.8 all over 8 plus 12. Do this one in your head, Mr. Dewick. I'm not likely to recommend you at all if you interrupt me when I'm teaching, you dumb idiot. Wow. Microsoft, figure it out. Teachers, use your products too. Maybe I can't do this in my head. Forget it. It's first thing in the morning. I put a 2 because I was typing too fast. .12 times 12 times 9.8. Is it 1.324? 1.32? A equals 1.32 meters per second squared. 3 marks if you got that. Otherwise, I would give you 1 mark for that, 1 mark for that, and 1 mark for the answer. Something like that. And then you all turn the page. Find the tension. Both of these are kind of yucky because no matter which mass I use to find tension, I'm still going to have to incorporate friction. I'll still go with mass 1. It's a little cleaner. So for mass 1, it's going to be tension minus friction 1 equals M1A. So tension equals M1A plus friction 1. Tension is going to be M1A plus mu normal force 1, which is going to be M1. A was 1.324 plus mu was 0.12 times 8 times 9.8. 8 times answer button plus 0.12 times 8 times 9.8. Wow, is it 20 even? That's a nice fluke. I probably should have been able to do that one in my head. What would I do? I would probably give you half mark for the original equation, half mark for getting the t by itself, half mark for the numbers, and a half mark for the answer. Elevator questions. You're in grade 12 now, not physics 11, but I would still encourage you for elevator questions, do a quick free body sketch. Now, you might be good enough that you can draw, Gurjot, the first one, the first free body diagram, and then just adjust the rest of them in your head without redrawing them. And in my homework, I'd probably do it that way. On a test, Kieran, I'm taking the time to redraw it quickly. So we're accelerating up. That means there's a winning force up. That means my equation is going to be Fn minus mg equals ma. They want the scale reading. No, they don't. What do they really want? So Fn is going to be Ma plus Mg, or Mg plus Ma. It's going to be 60 times 1.2 plus 60 times 9.8. Oh, this I can do easily in my head because it's 60 times 11. So it's going to be 660. Yes? Accelerating downwards. So what I could now say, Zach, is this. If I'm accelerating downwards on my original free body diagram that I've drawn, which force would actually be longer now if I'm accelerating downwards? Yeah, and so if you're good enough in your homework that you can look, I still think it's worth drawing that original one, if nothing else, but it would be, okay, it's going to be mg, wow, that moved, mg down minus normal force equals ma. We do the swappy dance. We get normal force equals mg minus ma. Really, it's either going to be your normal weight mg plus extra on the way up, that's why you feel heavier, or it's your normal weight mg minus something on the way down, that's why you feel lighter. Normal force is going to be 60 times 9.8 minus 60 times 2.25. You get 453 newtons. By the way, just for giggles, for either of these, what if I asked you to then tell me what the scale would read in kilograms? What's your conversion factor to change newtons into kilograms? It's divided by 9.8. I don't know if I'd ever do that, but I might. Oh, you know what? I would do that if I had given you a written question and it was worth 7 marks, which they almost all will be, and I felt it was a bit too easy, and I wanted to give you just one extra step that I could give 1 more mark for. Sure, then I'd say give me the answer in kilograms. I don't know if I've ever made up one like that, but that's where it would suddenly show up. If you ever wonder, why do we do these things? Oh, the question was a little too easy. Let's give them one more tiny thing to see who's paying attention. Really, Mr. Duick? That's mean. Yes. Yes. What's the key phrase, Mobeen, in C? So what that really means is your acceleration is 0, or what it really means is it's a tie. Winner minus loser equals 0, plus the mg over Fn equals mg. Which is going to be then 60 times 9.8. I should be able to do that in my head. It's going to be 60 times 10, which is 600 minus 12. So it's going to be 588, yes? D. What's the answer? This right here, D, is what led Einstein to start to think about general relativity. I was saying to Chang as he came in, how many of you have ever seen a YouTube channel called Vsauce? He released, if you're a physics nerd, a lovely one yesterday. It's 26 minutes long, but on your long weekend, take a dive into it. He does a great job of explaining how Einstein arrived at general relativity, what we mean by space-time curvature. He gives us some lovely analogies for how it's possible for an object to appear to be traveling to us in a straight line, but actually to be following a curve in space-time. And the only pedantic point I do have to say, though, did you watch it already? Did you catch where he made his little mistake? He said kilograms and pounds both measure mass. Pounds is actually a measure of force. Kilograms is mass. Slugs measures mass in the old system. But that's me being pedantic and obscure. The rest of it was pretty good. You could quibble about a few things if you have your PhD in general relativity, but it was a pretty good explanation. It's worth taking a dive down. I might even turn that into a classroom handout and watch it in Physics 11 next year. So what's the answer? What did you say? Give yourself a lovely score out of 19, please. Last day, we did what I said was the most important lesson of the unit. We went to angles, to ramps. The fancy word is inclines. We looked at the inclined plane, but really what I introduced, Paige, was an angle. And hopefully if I set the seeds right, when I said I was introducing an angle, your first thought was probably we're going to be using some components. And really what I taught you last day, Tato, was what are the best components to go with? Parallel and perpendicular. You could, actually, if you wanted to, leave gravity as is, and you could break friction into its horizontal and vertical components. And you could break normal force into its horizontal and vertical components, and any applied force or tension or into its horizontal and vertical components. But because we know all of those will either be in line with the ramp or at 90 degrees to the ramp, it's easier just to muck around with gravity. Change one force rather than changing all the others. But if you're bored sometime, come by after school. I can walk you through how we do the other transformation. But I also encourage you, don't bother. It's mathematically interesting, but it's more work for a less elegant solution. That's a double loss. So we said, what was our strategy? From now on, we're still going to draw a free body diagram. We'll still start with get the obvious one. Some hints I gave you, always label MG on the pointy side of the triangle. Some other hints that I gave you, when you're doing these diagrams, you probably want to draw these a little bit on the big side. If your teacher has to put on reading glasses to read your diagrams, probably you've done them a little small. I'm just saying, not calling anyone out on this or anything like that. Then we're going to break, before we go further, because normally then we said, are we sinking to the ground? Before we do that, you need to realize gravity is the one we're going to be changing. And I already noticed an example. In the last example, I was sloppy. I also told you I typically color that in and color that in to remind myself that angle is where that angle's going. I should have done that on the previous example. Then we could say normal force. Are we sinking into the ground? Are we flying into the air? And typically the normal force will be mg perpendicular. Why did you say typically, Mr. Dewick? Why not always? Oh, well, later on in your homework, as a nasty question, tougher that I'm going to ask you, it won't show up today yet. I'll do something like this. What if somebody's pushing in like that? Hey, you'll break that one up into parallel and perpendicular components as well. Okay, it's doable. Then we said friction, we have to think about whether it's acting up the ramp or down the ramp if there is friction. If we're sliding down the ramp, friction is pointing up the ramp. Or if we want to slide down the ramp, as in this question, friction is pointing up the ramp. If we're sliding up the ramp, how would we be sliding up the ramp? Somebody gave it a push. Friction is pointing down the ramp. We're going to just do this question, and then the rest of the class, I'm going to be throwing a whack of homework at you. I apologize, but this is what most of your test is going to be. I'll even be blatant. The only written question that won't be a ramp is going to be an Atwood machine where I ask you to find a missing mass. I'll do that because that's Physics 12. It's going backwards. Every other written question on your forces test is going to have inclines. I love example 8. I love example 8. I love example 8. Will you marry me? Why would I say that? Because you're creepy, Mr. Dewick? No. I'm almost making you a guarantee, I think. What two words did I underline, Alec? Sliding up. Or if I wanted to give you a different one, I could also have done sliding down. Those are the two variations on this. So in this case, we're sliding up, a rough ramp. Oh, and they gave me an initial speed, 20. A says, find the force of friction on the mass. B says, find the acceleration of the mass. C says, find time to stop. D says, find how far up the slope the mass travels before stopping. Now, I got to be honest, you will see a question like this in your future, except I won't ask you A or B or C. I'll expect you to clue in. I have to walk through that to find the answer D. Although, I'm going to show you how you can do it in one fell swoop and skip a lot of these steps. You're going to notice often I don't actually calculate friction separately. I just do it all in one line. How are we going to start this? Panic? No. How are we going to start this? I'm going to draw a picture. I'm going to draw mine. I think I can fit mine And mine will be fairly big, and hopefully yours will be... I'm going to do it right beside here. And I'm going to put the block... You know what? Since it's sliding up the ramp, I'll put it about halfway up, so that my brain won't suddenly think it's going to fall over. Now, we're going to assume this ramp has an infinite length, that it's not going to go so far that it falls over the end or anything like that, right? This is a model. 32 degrees. Okay. What are the forces acting on this mass? Get the obvious one. mg. That goes on the same side as the pointy part. Pause. Now we're going to break mg up into its components. It's going to have a perpendicular component. There's mg perpendicular. And I know to stop there because I want the next line to be parallel to the ramp. So I don't want to go further or shorter. mg parallel. Right angle goes there. What else? Are we sinking into the ramp like quicksand? Are we flying into the ramp into the air like Superman? There's got to be some kind of a normal force. What else? Paige, is there friction in this question? Yeah. Both the word rough and the fact that I gave you a mu in the question. Which way? What direction is this block sliding? So which way is friction going to be pointing? A little weird. And by the way, I should have said up is not acceptable, and you would have smiled sheepishly, and you would have said up the ramp, and then I would have said, okay, and which way is it? Down the ramp, because we have to be careful now with our up and downs. I think I went on that rant yesterday too, yes? Okay, making sure I'm covering all my bases. Taught the same lesson 4 times in a row, so you always got to make sure I covered everything. Page, I'm not sure whether that friction arrow should be bigger than mg parallel, smaller, or the same. But you know what? I'm not going to be that fussy anyways, because I'm not worried about whether they're canceling each other out because they're pointing in the same direction. So you could actually crunch the numbers on your calculator, and we'll get to that next lesson. What direction is this block moving? Up the ramp? Is it speeding up or slowing down as it goes up the ramp? So what direction is it accelerating? Down the ramp. So what direction is winning? Down the ramp. What's my equation? I don't know how many times I've seen students go mg parallel minus friction, because friction usually is a loser. It's not a loser in this case, though. I know horizontally it's almost always been a loser. It's not a loser in this case, though. Alrighty. Now, there's my equation. Let's actually walk through these steps. What does A want me to find? Friction equals mu times the normal force. I don't know the normal force. Oh, but look. I know another force the same size as a normal force. And it's not mg. Josh, which one? So I'm going to go friction equals mu mg perpendicular. What trig function was mg perpendicular? I wish there was a dumb way that my teacher had come up with that I could remember that. Now, if you blank, by the way, I did it again, didn't I? Color in that, so that I know what we're talking about. If you blank, you can just say mg perpendicular, opposite, adjacent, or hypotenuse. mg perpendicular, opposite, adjacent, or hypotenuse. Which one has adjacent? It's cos. If you're looking for a way, if you can't remember. So it's going to be mu mg cos theta if I go general. And if I plug in numbers, mu was 0.1. Fairly slippery ramp, actually. M6, G 9.8, cos 32. Uh, 4.986. I'll go 4.99. Is that right? Anybody else? Yes? And newtons. Okay. Really, part B, finding the acceleration, that's where I'll use this equation here. I jumped into finding the acceleration because I was just so eager. So there's my equation. Who's winning? How would I get the A by itself? Yeah, divide by M. That hasn't changed. So A is going to be friction minus mg parallel, all divided by M. Yeah. Plus, I did it myself. See? Silly. Now, you could plug in that 4.99 right here, but I'm going to do this algebraically. I have a feeling there's a good chance that my m's may actually end up canceling. Let's find out. Friction, we already wrote, that was mu mg cos theta. I just dropped that expression down to there. Plus, what was mg parallel? Those two lines. What? Oh. Do the m's cancel? So I'm teaching you some fraction math along the way here. Here's my fraction. How many terms are there in this fraction, grand total? 3. 2 big ones on the top, 1 on the bottom. Is there an m in the first term? Is there an m in the second term? Is there an m in the third term? Are there any plus signs or anything in between these terms? Aside from that one, is there an m in everything? Now, you really want the answer? When will it cancel? It'll cancel if it's a GCF. Look at the top. Is the m a GCF? Could you factor out an m? Yes. Do you have an m on the bottom? Yes, the m's will cancel. In fact, when I used to teach Math 12, I tried to... you know that I like to try and set up dominoes in your brain. So, for example, when I say angles, the first word that, did I say angles, comes to your mind is components. In Math 12, I would say to the kids, did I say cancel? Have I factored? Those were the two phrases that I would put together. Can I cancel? Have I factored? Because if it didn't factor, you couldn't cancel. You're doing trig identities later this year. Remember my advice. So really, I just get g cos theta plus g sine theta. It's kind of a nice expression. Pretty. Looks like the acceleration is... Oh, I did that. Wow, am I making dumb mistakes? Mu g cos theta plus, not minus, g sine theta. And really, I wish I'd done that on purpose. I hadn't. I made those sloppy mistakes. And I hope I said yesterday one of the issues is it's so easy to make sloppy mistakes because you're so proud of the tough physics that you've done and you're writing G down numerous times so your brain mentally checks off that you've written the G, but it might not remember that you need to write it a second time. Or, hey, what's mu? Because I wrote a mu already. What's mu? 0.1? 9.8 cos 32 plus 9.8 sine 32. Point 1 times 9.8 cos 32 plus 9.8 sine 32. 6.02. Meters per second squared. Cool. Now I've scrolled down, so I don't have access to the original information, but you folks do. What does C want me to find? Now let's use our defic approach. I'm going to go T equals question mark. What else has the question told me? Oh, time to stop. VF is 0.
VI.
What was VI?
20.
It told you? Good. Or I could have told you, instead of VI, I could have told you how far it went before it came to a stop. I could have given you the distance. Oh, what else do I know? Why is that wrong? Okay, now we're back in Unit 1, and so now we have to say, are we speeding up or slowing down? We're slowing down. Oh, how did we show slowing down for acceleration, Sharon? Negative. Now, you would catch it. If you missed that, you'd get a negative time, and hopefully I've taught you negative times are not allowed. I watched Star Trek once, and no, negative times are not allowed. Okay? And now, wow, Physics 11, I'm looking for an equation that has a VI, a VF, an A, and a T, and if there is one, get the T by itself. Yes? 0 minus 20 divided by 6.02. I'll use my answer button. 0 minus 20 divided by answer button. And I get negative, Mr. Dewick. I forgot to make my answer button negative, Mr. Dewick. I forgot to write in the negative, Mr. Dewick. I wish I'd done that on purpose. Wow, am I slumping this morning? But this is good. I'll put this on YouTube so people know that I do make mistakes, and lots of them. I would either say, oops, I forgot the negative in front of the answer button and just ignore that. Or, ready for my cleverness? Times -1. There's the correct answer. I would do that if I knew I was going to use time to find something else and I wanted to use my answer button for the time value. 3.32, yes? What else did I ask you to find? Okay, so I would probably, if I gave you this on a test, skip A and B. I would either ask you C and expect that you would clue in that you had to find the acceleration, and that you could find the acceleration without actually calculating friction if you just do it all algebraically because the m's cancel. My little math nerd heart goes pitter-pat when that happens. Or I'd just give you D on its own. Or both, but I wouldn't ask you A and C. So I have distance. VI was 20. VF was 0. A was negative 6.02. Oh, wait a minute. I now also have a time of 3.32. Talk to me. I think I'd use D equals VIT plus a half AT squared because the D is by itself already. Now you're saying, but Mr. Dewick, you're using time, which is a calculated answer. Yeah, but I'm using A, which is a calculated answer. There's no way to do this without using a calculated answer. So I'm in. I may as well pick the laziest way. D equals VIT plus a half AT squared. It's going to be 20 times 3.32 plus 0.5 negative 6.02 3.32 squared. 20 times answer button plus 0.5 times negative 6.02 times 3.32 squared. Oh, Mr. Dewick. Times answer button squared. And I get 33.2. Should it be a positive answer? I'm traveling forwards relative to our frame of reference here. Yeah, I'm okay with that. $33.2 meters. I think I forgot to do my touchdown dance. Good gosh. How did I forget that? Is that okay? By the way, if you're wondering, what's the next step, Mr. Dewick? Atwood machines combined with inclines. I have a tough time saying it's harder. It's longer. But please be more careful with your free body diagrams, components, or I think 2 different angles. Sure, it's doable. This is probably tougher than I'd ask. Here's the one that I warned you about, where what if you have another force? Break that one up into parallel and perpendicular components. Break that one up into those 2. Your normal force gets bigger. It's no longer mg perpendicular. It would be mg perpendicular plus that perpendicular component. But it's all handleable. For now, good, you're getting a good 20 minutes. I was hoping to give you a bit more, but that's okay. Why did this go back to the beginning of the lesson for some reason? Well, wrong button. What's your homework? So, I had said 1, cross out A, just do B. I'd assigned that. So now you can handle number 5. It's asking you to find time. What does number 6 want you to find? We could, by the way, how would you find the angle? You'd probably come up with a trig expression and end up going shift sine or shift cos or shift something. We could handle that, but I've got to cut corners somewhere with the flex block, so you can cross out 6. You can cross out 7. 8, but cross out A. Cross out B. Find the acceleration and find the time to stop. That's one very similar to what we just did. Number 9. What are they asking you to find in number 9? Mu. So it's going to be really similar to the one that we just did, but I think you're going to end up getting the mu by itself. They didn't give me the acceleration. I think they gave you enough information that you can figure out the acceleration. I think they gave you a VF, a VI, a D, or a T, or something like that. 15 is good. I skipped 10. Sorry, 11 is good. Why did I say 15 degrees? Wow. 10 is good. 10, skip 10. 11 is good. 12 is asking you to find an angle. You can skip that. 13B. $14 is good. 15 is deep. It's asking you to find the maximum value of F to remain stationary. Coefficient of friction is 0.6. And the minimum value of F. In other words, it's saying, how hard do you have to push to keep it from sliding down? Once you prevented it from sliding down, how hard can you push before it'll start sliding up? So 2 separate little free body diagrams. Think about it. That's a nice deep question. Class is yours, my angels.